So we're going to start by doing partial fractions. That's easy money. And then we're going to complete the square in our leftmost guy. And now we're going to do u substitution for x plus 1/2. And so du is dx. And then we're going to take out some constants. So we substitute in s for 2u over root 3. So that ds is 2 du over root 3. And so this leftmost integral is obviously going to evaluate to arctan of s. And notice our other guys, while they might look hard, are actually pretty easy, right? This middle guy is negative ln of the denominator, since the top is the negative of the derivative of the bottom. And our last guy is just ln of x plus 1. And so we do that and unwind our substitutions. And now we evaluate our limits by looking at what happens when b goes to infinity. And so plug those guys in. And notice all of our ln of 1s are 0, right? So we lose those guys. And now immediately we know that as b goes to infinity, our arctan term will go to pi over 2. So that's done. These two ln terms, though, become an indeterminate form of infinity minus infinity. So we take 1/6 out, and using the properties of ln, we can pop our 2 back over b plus 1 and turn this whole guy into a fraction like so. Then since ln is continuous, we can pass the limit in and expand. Now we can divide the top and the bottom by b squared. And so we get zeros for our non-b squared terms. And then ln 1 is obviously 0. So we drop that mess now, and then we evaluate, and yeah, we're done.